a quick overview of the quiz. So let's see, question. Okay, there we go. And let me copy this and let's bring up our notebook. New and add a page. So this is shown right here at the bottom, right? There are two ways to do this. You can either choose this as the reference node, or what do I always say? If you have a voltage source in a circuit, choose the negative end of the voltage source as your reference. So if you choose node 2 as your reference, then V2 is 0 volts. What is the value of V1? V1 is 10 volts. That leaves, let's call this V3. V3 is the only unknown. If you have only one unknown, you only need one equation to solve. So you write the KCL at the bottom node, assign branch currents, and you solve for V3. If we choose V3 as the reference, that is not incorrect. That is also correct. So if V3 is reference, we can write an additional equation in terms of V1 and V2. V1 minus V2 is 10 volts. And so we can express V1 as V2 plus 10 volts. We still only need one equation. And that's it. Anyway, you can think on that later after we are done. In the time we have left, I want to finish up all right, let's see. Upload. All right, I want to finish up the example 2 using mesh current analysis. In this example, we have 3 voltage sources, VA, VB, and VC. We are asked to use mesh current analysis to solve for the unknown quantities in the circuit. So first thing in mesh current analysis is identifying the number of meshes and assigning a mesh current. So how many meshes do we see here? Just 2, right? Let's assign mesh current I1 in the clockwise direction. And then let's assign I2. Let's call this mesh 1. Let's call this mesh 2. So how many voltages do we have in mesh 1? We have VA, then I have VR1, I have VB, and VR2, summing up to 0, right? VA would be minus, VR1 would be plus, VB is plus, and VR2 is plus. Out of the 2 resistors, R2 is in a shared branch. And so I can express minus VA plus I1 times R1 plus VB plus I1 minus I2 times R2 is equal to 0. Plug in all the known values. And what do I obtain? Let's see. My values are VA is -10 plus R1 is 5 times I1 plus VB is 9 and see I1 and R2. R2 is 10 ohms. So 10 times I1 minus 10 times I2 is equal to 0. Rearrange all the terms. And can obtain, this is -1, take it on the other side, I get +1. So 15 I1 minus 10 I2 is 1. Let's call that equation number 1. -10 plus 9, -1, -1 on the other side gives you +1. And 5 I1 plus 10 I1, 15 I1 minus 10 I2. Okay. So far, so good. All right. Then let's look at mesh 2. In mesh 2, I have 1, 2, 3, 4, 5 different voltages. So I'm going to start bottom. I have VR2 minus VB plus VR3 plus VC plus VR4 is equal to 0. Again, you can apply KVL any way you are comfortable with. This is the way I choose it. Doesn't matter which way you apply KVL, your equation would still be the same. Okay. VR2 again is a shared branch, but this time it's going to be I2 minus I1 times R2 minus VB plus VR3 is I2 times R3 plus VC plus I2 times R4 is equal to 0. Plug in all the known values. R2 is 10 ohms, so 10 times I2 minus 10 times I1 minus VB is 9 volts plus R3 is 5 ohms. And what I'm going to do is I'm going to combine R3 and R4 because they are technically in series or would be in series. They're in the same series branch on the right. R3 and R4 are in the same series branch. Even though they are connected on either side of the power supply, it's still the same branch, meaning the same current flows through them. So they are technically in series. So R3 and R4 can be combined. You can say that those are 5 plus 5, 10 ohms. So 10 times I2 plus VC is 1 volt is equal to 0. All right, so VB and VB, so it's -8. Take -8 on the other side, you get +8. And on this side, I get minus 10 I1 plus 20 times I2 is equal to plus 8. Call this equation 2. Solve this and let me know what the answers are. Anyone with the answers? Is it 13 by 20? Anyone with answers? You get 0.5, sorry, what is it? 0.5 for I1. And how about for I2? That's, well, what's the answer? What is 13 over 20? Anyone? 0.65. Oh, yeah. 13 over 2, yes. As a reminder, do not leave anything in fractions, okay? So if you're writing out a quiz, final exam, even as an engineer, do not leave answers in fractions. Always have the final answer, meaning you solve the division, right? So 13 divided by 2, half of 13 is 6.5, divided by 10, 0.65. I1 is 0.5, I2 is 0.65. Did anyone else obtain a different answer? Are we all in agreement? Hopefully. Okay, so 0.5 and 0.65. All right. So now once you have the values for both I1 and for I2, you can calculate the branch current through R2. You can calculate the voltage across R1, R2, R3, R4. You can calculate the power. You can calculate anything and everything. Okay. So for instance, if I1 is 0.5 and if I2 is 0.65, what is IR2? IR2 is the branch current that is flowing through R2. So what is IR2? Are I1 and I2 flowing in the same direction in R2? They're not. So the obvious answer, it must be a difference of I1 and I2. That's the most obvious answer. If they're flowing in the same direction, we can say it could be a sum of I1 and I2. But because I1 and I2 are flowing in the opposite direction, the branch current through R2 is a difference of I1 and I2. Which one is larger, I1 or I2? I2 is larger. And so This is I2 minus I1. 0.65 minus 5 gives us 0.15 amps flowing in the upwards direction. So IR2 IR2 is flowing up because I2 is larger than I1. So the actual, even though there are two mesh currents, one of them flowing down, the other one flowing up, the actual branch current through R2 is flowing in the upwards direction. All right, questions? The procedure makes sense? Do the steps make sense? Any questions? Okay. Yes. Yes. So the point or the question being asked is if I1 was greater, would it be flowing down? The answer is yes. So in this example, the current directions are not provided, right? In one of the previous examples, the current direction was provided. So the current direction was provided, if you would find the value according to that current direction. So let's just say, for instance, if IR2 was initially provided as going down, then we would have taken I1 minus I2. In that case, the answer would have been minus 0.15 amps. Okay, so if IR2 direction was given, then IR2 would be equal to I1 minus I2, and you would get minus 0.15. The magnitude obviously would never change. Only the direction, I mean, the sign would change depending on the assumed direction or the given direction, right? Nothing else changes. Current going up is plus 0.15. Current going down would be minus 0.15. Both are technically correct. Okay, let's see. Any other questions before I move on to, okay, super mesh. All right, so similar to super node, we have the concept of a super mesh. If anything, super mesh is even easier than a super node. All right, so let's say you have two current sources in a circuit. Okay, one or two current sources, let's say. So in that case, you would not be able to apply KVL, right? If you have a current source in there, you cannot describe a voltage for that current source. So what we do is we take the meshes that contain that current source, whether it's one mesh or whether it's two, and we apply KVL around that loop. So we'd combine the two meshes together. Excuse me, we'd combine the two meshes together and we would apply KVL around that entire loop containing those two meshes. There's no other difference whatsoever. KVL will apply as it is, nothing else changes, okay? The important thing to keep in mind though is this. Even though you're combining the two meshes, the two mesh currents remain independent, okay? The two mesh currents remain independent. So if I was to write the KVL around the outer loop containing that current source, that would comprise, or that would be known as a super mesh, because it is combining two meshes together. Okay, so when you combine two meshes together, that is known as a super mesh, and you simply apply KVL around that super mesh. In other terms, you're taking an electrical loop, not a mesh. That's all it means. And if you wish to apply KVL or write KVL, we still must take into account the two mesh currents separately. So if I start at the bottom left corner and I apply KVL in this direction, I would have this KVL would give me plus 1 times I1 plus 2 times I1 minus I3. Again, this one is the first resistor. I'm starting at the bottom left corner right here. So bottom left corner, 1 ohm times I1, the mesh current I1. Then the 2 ohm resistor, 2 ohm is shared between I1 and I3, so it's I1 minus I3. And then I get to 4, and 4 is I2 minus I3. Again, even though I'm combining the two meshes to apply KVL, it's only to apply KVL. The two mesh currents still remain independent. Do not combine the two mesh currents, okay? So then I1 applies to 1 ohm, I1 applies to the 2 ohm, and then I2 and I3 apply to the 4 ohm. Does that make sense to everyone? So you can combine two meshes together, apply KVL in two meshes, and we just simply call that super mesh. All we are doing is we are applying simple KVL. That's all we are doing. Remember, KVL applies to any electrical loop, whether it's a simple loop like a mesh or any of the complicated loops. So KVL still applies, KVL still works. But because we are using the technique of mesh currents and mesh current analysis, we have to take the corresponding mesh currents into account. Does that make sense to everyone? That's all a super mesh is. Even more straightforward than a super node. Okay, you're simply combining two together and applying KVL around that outer loop. And then finally, to complete this would be plus 10 equal to 0. That's all it is. Okay, that's all it is. All right, any questions? Okay, we'll end class here today. Please review the material and then let me know if you have any questions. Homework will be forthcoming based on these topics. And next week's topic would be mesh current analysis for quiz.